Hey folks, Sam here for a bit of a code along session, and in this one we're going to look at me writing some integration tests for a storage layer. So if I go and have a look in the service here, we've got two methods on our storage layer currently, and one of them is for putting a record in and the one's for getting a record out again. It's very simple, and we've got an implementation of that storage layer that's going to be using DynamoDB to perform that storage. And a lot of this kind of thing is very common if you come from more of a Java background or C# or similar, but I think it's less common in the JavaScript or TypeScript world. I see a lot less of this setup where you've got an interface or an abstract class defined and then other classes that implement it. And I don't know if that's just because things like dependency injection aren't quite as popular in JavaScript or TypeScript, but maybe that's just my experience that's skewing that view. So the idea is that we don't have any implementation yet. The service doesn't do anything, and we want to write some tests to make sure that it actually works properly. So as we start to write the implementation, it all fits together. And I've got the local version of DynamoDB running in a Docker container here. This is a Docker Compose that's been adapted from the AWS website, and that's just so that I can run these tests on my local machine without having to use any real DynamoDB. And that's the same for in a CI environment, continuous integration environment. We can have it use a test DynamoDB as well. Now, there's a lot of arguments for and against this kind of mocking or stubbing where you're using a fake version of the external service. In this case, I think that it's pretty harmless given that this container is set up by Amazon themselves, so should be a really good mock of DynamoDB, and they've got some caveats listed on the website that talk about the differences between this version and the real DynamoDB service, but I don't think any of those are going to impact this particular project. But obviously you would want to read those if you were doing this yourself and make an assessment about whether this kind of mock or stub is appropriate or whether you want to use the real thing. And in most cases I would advocate using testing against the real thing or as close to real as you can get. But obviously there are caveats with that. In this case, I could run this application, these tests, when I'm traveling somewhere with no Wi-Fi, when the internet's down or similar, and they would work just fine. But obviously, if we were using the real DynamoDB for testing, then that wouldn't work. And also, we don't have to have any AWS credentials set up or an AWS account that we can use for testing to use that. So let's go and have a look at the tests so far. So I've got a DynamoDB client that's going to get shared between all of these test methods. And we've got an endpoint set. I've provided the facility to override it with an environment variable, or will default to localhost 8000, which is going to be going to our Docker container. Then, because I don't want test runs to conflict, so if you imagine if you're running the tests multiple times for whatever reason, or if you and someone else are running the tests, or if the test resources don't get cleanly torn down at the end of the test for whatever reason, then we don't want the tests to fail in the future. We want them to run reliably. And as a result of that, I'm using the crypto library just to make a little random string to stick on the end of our test table name. So I've got the before all statement where I'm setting up the table. So let's clear that console down to make some room. So you can see I've just got a very generic key attribute because it's a DynamoDB setup. So we might be using different styles of keys for different access patterns using the same table. And then we've got a name, the randomly generated one earlier, and we're going to do pay per request billing rather than provisioning a specific amount of capacity, just because this is a test database, and that billing model works very well when we're doing an incredibly low number of requests. And we're going to put server-side encryption on and give it some tags, partly as a kind of a bit of a best practice thing of getting into the habit of doing that, and also the tags let us identify the costs and where they're coming from. So we've got an AWOL one for project, and then we've got another one for source because this is an integration test. So you could look in the billing manager if these tags are set up as cost allocation tags, which is a configuration step. You have to select those as cost allocation tags. And then an after all statement, we're doing a little bit of cleanup. And in my experience, some of these cleanup methods can sometimes go wrong if there's a race between operations, or there's some data still in the item, because some services or systems, if there's data still in it, deleting the object resource is harder. So I'm predicting that that's going to happen, and I'm putting a little console output to warn the person if they ever see it that we can delete the DynamoDB table. Then I'm just rethrowing that error to make sure that the test runner reports it as a failure. So I've got some scenarios for each of our two methods that we're going to test and build: put day record and get day record. And I've just come up with these from how I think the application will be used. And I'm using Jest to run these tests. Purely that's a preference thing. I've used Mocha and Jest quite heavily. I like Jest for the cases I use it in, and that's just my choice. I've nested these test names within several describe blocks, and again, that's really just my style thing. That's how I like to do it. It doesn't really matter what you choose to do. It's just got something that works for you and is easy to read, easy to write, and easy to understand. So we've got a test case here. When no existing record exists, it saves the record. When an existing record exists and it hasn't been updated since we retrieved it, it saves the record. And if you're wondering, well, why do we need to know if it's been updated since we retrieved it? And that's because there are no transactions. Well, there are transactions in DynamoDB, but we're not going to be using DynamoDB transactions. And all we're going to do is get the data from the database, do a bit of an update, and then put it back again. And we've got to make sure that in between us getting that data out and putting it back, no one else has changed it, because we'll lose their changes. And so we're going to use a conditional write feature of DynamoDB to do that. And so we want to test that's working as we intend, and we'll write a failure case, then we'll implement the conditional writing, and then we'll crack on again. And then for getting the data out when no record exists, I like a nullback, and when a record exists, we want it to return the record. So these are to-dos at the moment. So if I open up the terminal here, and we run these, and you can see I'm using pretend AWS credentials, because this is just running against a local service mock rather than the real AWS. And then there you go, it runs and it passes, and we get some coverage data, which is pretty rubbish at the moment, but we haven't written any code and we haven't written any tests, so that would make sense to be that way. So let's do the get side first. Why not? So I'm going to get rid of the .todo and let's crack on with an async function body. So let's get our data store ready, and then let's call the method on and see what happens. So we can say the data store is a new DynamoDB data store, and then we want to say await, and we're using await before expect because we're using the promises feature of Jest. So let's say data store.get day record, and let's give it a date. So we need to know that date isn't getting used anywhere else, and that's part of the reason that we're using the random table name here, because we don't want to conflict with other test runs or other things. So I'm going to use a date that is going to be unique just for this test. Let's use the year 2000. So go the same date as it is as this recording, which is the 16th of October. So let's try that. And we'd say that because it's going to return a promise, that we want to have it resolves to equal null. And if we really wanted to, whoops, I didn't mean to delete all that. We could use to be instead, or similar. Sometimes there's another method like to be undefined we can use in this case, but which one we'll just say to equal null. And then we can run the tests again. We will see that we now have a failing test. So here we go. Expect received resolves to equal expected, and then expected is null, and then received is undefined. And that's because the method hasn't been implemented at all. It's not set up. Then let's do one where we actually expect the record to be in existence. So let's say data store equals new data store. Oh, sorry, DynamoDB data store. And let's await expect the data store dot get day record, and then we'll choose another date. Let's have 2010, and let's do Christmas Day. Why not? And then let's resolve to equal. And now we want a particular object back. So let's go and have a look at our class again. And you see, so get day record returns a promise of day record, and day record has these fields in. It's got date, last updated, and merge requests. So let's go back here. And now Jest isn't giving us a type for this this object here. So there's a chance that we can fall out of sync with the return type of this method. So what we could do instead is to say the return type of that method. Oops, and I've got the syntax of that slightly wrong. So DynamoDB get day record. So let's read the error message, and there we go. Okay, so that looks about right, and that will stay in sync with whatever our method is. And now let's see if we get any helpers to understand that. So if we put the day in, and let's put the date as 2010 12/25, and then let's see what the error is. So conversion of type, this one may be mistaken because neither type sufficiently overlaps the other. If this is intentional, convert the expression to unknown. So I'm using return type here, but the value coming back has to be a promise. So I'm not sure actually if I can get this out of the promise here, so we can just use the value. So maybe that wouldn't work like I intended. Let's just change that to being a day record then. So we have a look on there, and we are missing date, last updated at, and merge request. Oops, so I should have put date there. And last updated at, let's say this is going to be 2010 12/25 at a particular time. Let's say it's 10:25 AM, 1 second past, and in UTC. And that looks about right for our timestamp. And then we have to add in some merge requests as well, and this is to do with this project is actually dealing with notifications for Gitlab merge requests. So merge requests are the equivalent of pull requests in GitHub if you've used GitHub. And so, whoops, I've got the wrong type again now. I was supposed to use a object, and the key of the object I believe is going to be the merge request ID. So let's say merge request 1, and then we go merge request, and we'll be missing some fields here. ID, title, author, project status. So let's say the ID is 1, the author has an ID of 1, and their name is James. Title is my cool set of changes, and let's have the project has an ID of 123, and the name is example project. And what else are we missing from here? We're missing status, and the status, let's go put it as let's say opened. So it's an ongoing merge request, and we can add another one in as well, just so then we're testing the functionality of when there are a couple coming back. And let's copy and paste that test data and then change it slightly to be quite similar but a little bit different. And a few of the fields are different in those two. So we've got another test method, and we're making sure that that data comes back. But we're not actually setting up anything in the database to make sure that data is available. So we could, if we wanted to, use a DynamoDB client to insert this data ourselves, and then we could check that it's coming back out of DynamoDB in the right shape. Or we could use the put day record method to put the data in for that particular day, and then we could get it out again. But obviously if we use put day record, we are testing both together. We might want to test them in isolation. So if the tests fail, we know exactly where it's gone wrong, exactly what's got the wrong behavior. So they're kind of pros and cons in both cases. In this case, I think we're going to put the data into DynamoDB ourselves. So let's send it a command. And this is the version 3 of the AWS SDK for JavaScript. And so it has a bit of a different way of working, a bit of a different syntax to some of the older stuff that you might be familiar with the AWS-SDK package. So let's do a put record. Put document. Put document. I can't remember what it's called now. To put a document into DynamoDB. I thought it was something like put document. Let's have a look on the AWS API Docs for DynamoDB. Let's make that a little bit more specific. Is this the old documentation? Oh yeah, this is the old version of DynamoDB. But that's fine because we can guess the IP. We can guess the operation name from that. So we have put item. There we go. You can tell that I haven't done this in a while. So we're going to do put item command, and that's going to take a table name, and it's going to take a probably some form of key. Let's see what the error message is, what we're missing. So missing item, and that's going to be our actual data. Let's just go and have a look at the put item command object, and that's taking a put item command input, and that extends put item into lots of indirection here. And so that's taking a table name string undefined. Yep, we've got that in there. We've got an item, which is going to be the syntax attribute values. We've got an expected parameter that's deprecated, so we're not going to use that on return values. We don't really care about return values. We don't really care about returning the capacity that we use for that operation, or metrics. Conditional operation is also deprecated, and conditional expression is what we'll be implementing later to make sure that no one's changed this data since we last used it. However, we don't want to implement that just yet until we've written the tests for it. So we'll leave that for now. Expression attribute names. So I don't think we're going to do anything with expressions. I think this is working around reserved words, of which there are an awful lot of reserved words. I don't really know why. So if we want to have a key that uses a specific reserved word, we have to do all sorts of song and dance with expressions. We're not using that. And then attribute values, and yeah, so this is more expression stuff, and we're going to try and avoid using expressions at all costs. Let's just go and have a look at that reserved words list. Yeah, there's a lot of stuff here. Like, wow, this is a lot of words. I hope we are not using the date. Is that one of the reserved words? Do not use any of these words as attribute names and expressions. It is not case sensitive. Great. Okay, well we might rename the field date then when we're saving the data. How about last updated at? Okay, last updated at's not on there. That's good. So let's get rid of that. Get rid of that. So we want to make sure that we can still save our shape of data, our day record. So we've got merge requests. I doubt they're going to have merge requests as a reserved word. No, they've got the word merge, but that's fine. So okay, so date's the only problematic record there. So let's go to our data store and put in the data. So let's say we're going to have a key, which is a string, and the key is going to be this date here. And then we've got the rest of the fields. So we can't use the word date without using the expressions, which I want to kind of avoid. So let's just say it's record date, which is a bit of a naff name, but there you go. Then we want the rest of it. So we've got the last updated date to save. So let's put that in there, and that's going to be this string here. And then we've got the merge requests, and the merge requests are just going to go in pretty much as they are with the DynamoDB syntax, which is a little bit painful. So we've got is it O for an object, or how do we specify an object in there? Let's go and have a look for the DynamoDB docs again. Put item. So lots of layers of indirection. Then item takes a key. Whoops, come on, where has it gone? Oh, how have I lost that? So I'm going to have to go back and get it again. Here we go. Item key of a string to an attribute value, and so that can be a B or bool, BS, L, M, N, NS, null, S, SS, and unknown member. So S is a string, N's a number, B is binary, which we're not going to use, SS is a string set, NS is a number set, BS is a binary set, M is a map, L is a list, null is null, bool is boolean, as you'd expect. Okay, so that's fine. So we're going to use a map, I think, for this object. So we want an M. So we can go M, and then inside the map we're going to have this couple of objects here, and then each of these keys themselves is going to be another map. So let's indent them again. Now let's do the first one. So ID is going to be a string. Author is going to be a map. So we use M again. Things get very quickly, verbose very quickly with DynamoDB, but it is web scale. And again for name. And then we want for title, that's also a string. For project, that is going to be a map. Let's pop those in there. And ID is going to be a string. And name is also going to be a string. Status, you guessed it, it's a string. So we've got to do the same here. So we're going to have a map with all this lot in. And we're going to have a string for this. This one's going to be a map as well. And we're going to have a string here. We're going to have a string here. We're going to have a string here. This time we'll have a map. And then we're going to have a string and that's it for everyone at home, that's a string. And another string. Cool, so this test method's getting really long. It's up to you, is like whether you think this is okay or whether you think it should be refactored out into some other form. You know, some people would put this test data in an object somewhere else. Some people put this test data in a file somewhere. We're going to leave it in the test method for now, so everything is really closely located to each other. But you know, a lot of people would prefer a different setup to this, and I completely understand that. It's a bit of a preference thing, and the font size is quite large for this recording, just to make it clear on a higher resolution. But if this was a normal font size, you get quite a lot of this onto one screen. And so, you know, I'm not too fussed about having this all on here. So let's so we can expect to get the day record results to equal this value. So let's run the tests again. And we've got two failures. So one of them's getting undefined back, the other one's getting undefined. So we're not getting any data back at all, even when we're putting data into the DynamoDB table. So let's go over to the actual implementation and let's implement getDayRecord. So we can think of some kind of table name, and to be honest, we don't have a table name anywhere in this class. So we're going to put one in the constructor, and we're going to say private read-only table name, which is going to be a string. We don't need to bother calling super because this is the super's parent's an abstract class. I think TypeScript's going to complain and say we have to, though, even though the data store abstract class has nothing in it, and you know, it doesn't have anything but a default constructor. So we'll take that table name in, and we use private read only to make it a property, which is very handy, and that means we can then do this table name in future calls. So we're also going to need to build up a DynamoDB client. So let's pop that in above the constructor. Let's say private read-only DDB client. Oh, let's go DDB, why not? Let's say that's going to be a DynamoDB client, which is coming from the AWS SDK / client DynamoDB package. And that's going to be a new DynamoDB client. And that takes one argument. That's just some config. So now we're in a bit of a conundrum because we're going to have to override some of this configuration because we're using a local endpoint for DynamoDB. And so we could pass in some configuration here, we could pass in an endpoint here as a string instead, or we can pass in a whole DynamoDB client and let people have a custom one. So I think for now we'll just take in the whole client. So let's put it at the start actually. And let's say private read-only, we'll put it at the end and make it optional. Yeah, let's put it at the end and make it optional. Read-only DDB, that's going to be a DynamoDB client equals, and then we can have a default value, so people don't have to provide a client if they don't want to, and we'll just use a default one. Cool, so we've got that set up. We're taking a table name and a client to do some work with. So let's get the raw record from the database. So we say record equals await DDB dot, so we're going to make this an async function to use await. This.ddb.send, and we're going to do a new get item command. And that will take a table name, which is going to be this table name, and it will take a key, and we're going to have a key called key, and that is a string, and that's going to be the date. And so then we can say if record dot. So what we're getting back, so record dot item. So I'm going to assume that if the record doesn't exist, then item's going to be something falsy like null or undefined. So we'll say if the record item will do one thing, we'll sort that out in a second. Otherwise, we will return null. Okay, so type null is not assignable to type day record. Okay, so my interface is slightly wrong. So let's look at the data store. So we're either going to return a promise of a data day record or null. And then we're going to change our implementing class to have that same type. And then, yeah, now we're fine to return null. So let's handle this case. So if we do get an item, we've got to turn it from the DynamoDB form, which is that big mess of an object here, back into a form that's actually sort of human readable and more manageable in application. And the syntax here, where we've got objects with a type for the attribute, so like a string or a map or similar, is a DynamoDB feature. And we don't want to really expose that to our users because we want to be able to change the data store in the future if we want to. So maybe we use a mock data store for testing. Maybe we use a relational database or another NoSQL database like MongoDB, a bit of Postgres in there, a little bit of Postgres, whatever we fancy in the future. And so we don't want to have this shape coming back out of our class. We want a nice, easy to use one instead. So we're hiding the details of the implementation here. So we're gonna make up our day record again. So we've got to have a date, and that's going to be record.item. We had to call it record date, didn't we, to avoid hitting the reserved list, the very, very long reserved list. And that's the string. And then I think it's going to complain because DynamoDB puts everything as undefined, which is frustrating. And realistically, we could validate this here and then throw an error if it's not found, and that would make sure the type's correct. Or we could put an exclamation mark on there and say it's definitely going to come back. We believe it to be there. So in this case, I'm not going to do some validation, at least not at the moment, because we're the only person changing this database. And so we'll just assume that the data in there has been put in by us and been put in the correct format. So let's have a date in there. Then we've got last updated at, which is going to be the same sort of syntax again. And then we want our merge requests. Now in this case, we've got to take the map style structure here and turn this back into nice friendly objects. So let's do record.item.mergeRequests.m. and then we will assert that it's going to be there, and we're going to do a reduce on that. And so we're going to have two parameters, out and the output object and the current object, and then we're going to start with an object which is going to be is it going to be a list of merge requests, isn't it? Oh, sorry, no, it is a record. It's an object. So record string merge request. This is probably going to complain, because we can't reduce on an object in its raw form. So let's do object.values from that map. And we could use the key, because the key is the merge requests ID, but we have got the ID in here as well. So maybe we could use object.entries instead, and then we've got a key to value, but both numbers should be the same. The ID and the ID of this item in the object and the ID of the ID field should be the same, hopefully, unless we've made some nasty bug. So that's going to complain because it doesn't know what the type of our output is. It doesn't know what the type of the current is, because it can't really tell when it's coming back from DynamoDB. So let's give this object a type here. This is going to be a record of string to merge request, and so that gives us a bit of a type for the output, and let's at the end of it just return out at the end of this method. So that's happy now. I wonder actually if we could remove that. I don't know if we need that or not. The output's then got no type, so let's pop that back in. So at the moment, the reduce isn't doing anything. It's not putting any objects in anywhere. It's just returning the output object every time. And so coming into this reduce, we've got two objects. We've got an array with two items in. We've got a string and an attribute value, which is the key and value. So let's destructure those out of our cur variable. And then let's do something with it. So we can say out at key, which is going to be our ID, is going to be value, and then we'll have to make up our merge request objects. Let's actually start an object here. Just going to check why this is complaining. Type empty object is missing the following properties from that. Yeah. Oh, that's cool. Yeah, that's all good. It's because we're going to put those in now. So it's got an ID, which is going to be the value dot m to get inside the map dot ID, and then dot s. And again, we're going to assert that these are okay rather than validate them, and that's just a choice we're making. It's got trade-offs to it, but I'm happy with that choice for now. Then we want to give it a date. Sorry, merge request doesn't have a date on it. Let's just go and have a look at the merge request object for a second. So day record's got merge requests. Merge requests have ID, title, author, project status. I'm just going to add, I think we might also need a created at date here, so we can do a bit of sorting later. I'm just going to have that as a string. I'll just have that as an ISO style string. So let's pop that on there as well. And then in our test data, we're going to have to add in the created at field. And let's say that this one was made on, where's our last updated time? Let's steal that time string. Yeah. And let's put it a very similar value. So maybe that was, I don't know, it made it 9:05 and 1 second. And let's go and pop that in the second merge request as well. And that's going to be 8:55, for example. 3 seconds, why not? And then in our test is now failing, or no, sorry, it's not failing, it's not compiling, because this is no longer a valid day record. And obviously if we didn't have that as day record on there, we'd be testing that it's the wrong sort of shape. We wouldn't be checking that the expected value is the correct shape. And so this looks okay, this looks fine, but this isn't a valid day record. So let's pop that back on there, and it just makes it a bit easier to see that there's something wrong with our test. And we can put the created at field, and we then need to go and get the value from our first one and the value from our second one. Created at there, like so. Great. So we've got a very big test record as we've discussed earlier because of all the data in there, and we can put it somewhere else, but then it's a little bit harder to visualize where it's all coming from. So in this case, I'm going to leave it in there, and I'm happy with that for this case. That's fine. Now we're getting an error because we've added that table name and DynamoDB client to our DynamoDB data store, and so we've got to pass those in as well. So let's do table name and DDB, and let's do here again table name and DDB. Let's go and finish off that implementation. So we've got our reduce here, and so we're going to put the fields in. So we've got a title field, value.go into the map, and then we go to the title, and we're going to assert again that this is all there and happy and fine. So we're bypassing the type safety slightly, but we're going to trust that it's okay. And then we also want a created at, and again we go inside the map, and we get the created at, and again we get the string with the same caveats. Then we have our project, which is going to be an ID, and that's so they go inside the map, go to project, go inside the map, get the ID, and that's a string. Welcome to the wonderful and weird world of DynamoDB objects. And then we want, in addition to the project, we would like the author, and that's going to be the same thing, ID and name, but for the author instead. So let's make sure I copy and paste the correct ones in there. What else do we want? We want a project, author, and a status. So that's going to be value.m to go in the map.status, and that's also a string. And oops, I've made that an object. I didn't mean to make that an object. That's supposed to just be like that. Okay, so here we've got an interesting thing. So in our type for the merge request, we are saying the status is an enum. It's only allowed to be specific values. Oh, sorry, let's go in this one. So you can see status is a merge request status, which is an enum. So it can only be one of these things. But in our DynamoDB table, DynamoDB doesn't have the concept of enums we can store. So it's just coming back out as a string. So again, we could validate it. We could make sure it's a valid status, or we can just say that it is one and hope that everything's fine. But it's up to you as to whether you think it's important enough to do that kind of validation when you're getting data from a place that's not type safe and bringing it into TypeScript. And for things where you're dealing with, say, user input or API responses, where you're not in control of the shape of that data, you're trusting that the shape of that data is going to be correct, then you might want to do some validation. But again, it's a trade-off. It's whether you think it's important for that use case. Okay, so we've got a day record, and we've got the code to bring it back into a normal shape from the DynamoDB version. So let's run the tests and let's see what happens. So we've got one failed test again, and we cannot read the property of undefined. So here's an area where if we had that validation, the validation would fail and tell us that something's wrong, but instead we've just been like, yeah, it's cool, it's all going to be there, it's fine. And so it's much harder for us to diagnose what this error is. And so, we could go back and add the validation if we wanted to, or we have to try and work out where that error is coming from. And obviously that error, Jest isn't giving us a full stack trace for that, which isn't very handy. It's not very helpful. So let's pop into our test for a second, and let's wrap this assertion with a try catch, just so we can get a better error out. Oops. And let's log out the error and then rethrow it to make sure the test still fails. We don't want to pretend that it's going to pass. I'm just going to run prettier while we're at it to get that all formatted nicely. So let's see if we now have the full error stack trace. So cannot read property s of undefined, and that's expect, and then here's the spec. And then, oh yeah, we've completely lost the original error, which is very unhelpful. So let us take that try catch out for now, and then we're going to reformat that. Oops, reformatted that incorrectly. Let's go into the implementation, and when we're pulling everything out of the database, we can do the try and catch at this stage, just to get some more data. Okay, so here we go. So this is where we're going wrong. So the last updated at is not found in that data. The record date is there, which is good. That's a good start, but the last updated at isn't here. So we have that in the assertion. Are we actually putting that into the data? So yeah, last updated date. So I've gotten the wrong field name there, and as a result, that's going to fail. So I should have put last updated at. Oops, rather than the last updated date. Yeah, okay, that's the correct field. Let's just look for last updated date, just in case I put it anywhere else. No, I haven't, that's fine. Let's run it again. Okay, so we've got some errors here because the name is coming back as the wrong value. So I must have made a bit of a mistake there. I'm going to clear off that try catch that we had before. Some people would put more try catching and error handling in each individual method and do some logging around that. It's up to you. For this use case, I think once it's built, it's very likely to just keep working forever, and so I'm happy with it in that form. But you've got to do what is right for your use case. So let's see what I've done here. So project ID value project ID up. So I should have put this as name, but the tests have caught that, which is very handy because it means that we can verify that it works. Cool, so we've got 2 passing tests now, which is good. Also, because we've got coverage turned on in Jest, let's go and have a look in the coverage folder. And in LCOV report, we've got index.html. Whoops, not a fav icon. Let's go and have a look at that index.html. Oh, of course, it opens in the editor. And let's go and have a look in source services at our DynamoDB data store, and you can see that the get day record is completely covered. So we haven't missed any branches there. And coverage isn't perfect. Coverage doesn't tell you that there are no bugs, doesn't tell you that everything's working as it should. But at least it can help us find areas that we haven't got tests for. And so put day record isn't tested at all yet because I haven't done those tests. So let's crack on with the tests and the implementation of put day record. So let's start off in our test method here. So when there's no existing record, we want to save it. So let's start this off. And again, we're going to use a date that we haven't used before. And I'm actually going to steal this this test data from the other test method here. I'm going to pop it up to the top. And I'm not going to do as day record. I'm going to make it a variable that is a day record. So let's say our record, which is a day record, equals that. And let's just run Prettier because it's gone out of whack. For some reason, editor integration with Prettier isn't working for me, so it's a bit frustrating. So we've got our record, and it's the right shape because the variable is the right shape. So unless we change the type of the method, it's okay. I'm going to put some different test data on this so we don't get confused between tests. If we see test data in some form and we want to think, oh, you know, which test updated this? Which test is this data coming from? So I'm going to choose some different values just to make it easy to find. And let's have 2 merge requests, and this time we'll do a bigger project that's got a lot more data on and 2 very different IDs for merge requests. And we put those in, and let's make the creation at date. It's going to be on the same day as the notifications coming out. So it'll be July. And we can say this was 1 o'clock. We'll say this one was 2 o'clock. And the author's going to be still James, but with a different ID. Project is going to have a different ID and a different name, but we'll keep the title the same. I'm quite happy with it. All the other stuff is changed. Let's have them both. We'll have one merged and one opened. Cool. So we've got some different unique test data, and we've got a date that we haven't used at all, which means there's going to be nothing saved for this day so far. So let's go and save that data in. So after the record, we can say await. Expect. Haven't initialized our data store yet. So let's say the data store dot put day record. That's going to take our record resolves to be undefined. I think we said that it would return a promise void, which is undefined. Yeah, we did promise void. Cool. So let's run that. See what happens. Oh, sorry, that's Prettier, not the tests. Okay, so that's passed so far. So we've called the method and didn't error, but it didn't actually verify the functionality worked correctly because we haven't implemented put day record. It's just a dummy promise resolve. So we need to make our test go further to make sure that it actually resolve actually verifies what's happened. So we're going to use the get day record here. And again, it comes with the same caveats. You know, we could manually verify the shape of the data in DynamoDB, or we can use the getDayRecord method. And if we use getDayRecord and there's a bug in that, then potentially all the tests will fail, even if the problem is in getDayRecord, or we can use the DynamoDB shape. So let's tell you what. Let's use the DynamoDB shape as we did in the other one. So we're going to send a command to DynamoDB. In this case, it's going to be a get item command. And it's going to take the table name again, and it's going to take the key. The key is called key. It's a string, and the string value is going to be the date, which is up here. So we can do record.date, actually, why not? Cool, and I'll run this through Prettier in a second. So we're getting the item, so let's say the saved item is that. And let's just do expect the saved item to equal, and then let's do an empty object. And then I'm going to run that. And suddenly, the item coming back is undefined. Oops, sorry, I should have done saved item dot item. And suddenly it's undefined. It's not even an object. It's just completely undefined. So the record isn't getting saved, but the test is now failing. So let's run pretty quickly. So now we can go and do the implementation side. So let's do some implementation. So let's make this async again, so we can use await, and let's do a put command. So let's send a new put item command. Sorry, not put command. And then table name is going to be the table name. Whoops, this dot table name. The key, where do we set a key first? No, we just use item. Yeah, here we go. So now we've got to do the reverse of what we did in this thing here to build up the correct shape for DynamoDB. So let's go and steal one of these bits of test data or the test setup where we are putting that data into the table, this item here. And let's reuse that, do a bit of recycling. So this time, rather than having a static value for the key, it's going to be the record's date. For the record date field, it's also going to be that. And the key and the record date are currently the same value, but we might change this key. We might put, say, a prefix on it, say like date, if we want to store multiple different views on the same data in one table. But let's leave that for now. And let's use last data for the record. And then for merge requests, we've got to do this a number of times. So let's do a reduce again. So we're going to, we'll do object.values, or should we use entries? Let's use entries, why not? So we're going to take in the entries, which is going to be the records merge requests. And then we're going to have an output variable and a current item. And then we're going to have the output shape, which is going to be a record of strings to attribute value. Is that the right type in DynamoDB? I want to use the same sort of type as they produce. So let's look at put item request, or put item input, is it? Yeah, put item input. Key string to attribute value. So cool, let's return out to make sure it gets it as it wants. Oops, sorry, I forgot to put the object reduce. I got distracted by the object.entries and didn't finish writing out the reduce instead. So we've got dodgy syntax here, object.entries that, then there's our function, then there's that's going to be an as rather than a colon. Reduce does not exist on object.entries dot reduce. There we go. Can we program today? Maybe there's some programming around. Cool. So we seem to have a bit of a mismatch. The property unknown is missing in type record. So the result of this is going to be in a map. So let's pop it in a map like that with the big M. Okay, cool. So now we can actually produce DynamoDB shaped records for each merge request. So let's copy in an example one. So here is an example one. Like this, I think, have I copied enough brackets? Potentially, we'll find out. Found it a bit. So output at key. Oh, sorry. Let's destructure the key and the value from our current record first. There we go. So output at key is going to be a big old DynamoDB shaped object. So it's going to be a map. It's going to have an ID, which is going to be the merge request's ID. It's going to have an author, and that has an ID which is value.author.id. And for the name, it's the same, value.name.id. Value.author.name. Sorry, not that. Then title, it's going to be value.title. And project is going to be a very similar thing again, value project ID, value project name. And the status, value status, and created at, value.created at. Okay, so that should put some stuff in our database in a rough sort of shape, we hope. So let's run the tests again. So now we're getting back a full record, but we're asserting that it's an empty object. And I asserted that it's an empty object on purpose in our test here. You can see that we are checking for an empty object here because I wanted it to fail so that we'd get that big output from Jest, and then I can do a bit of cleaning up on this and make it available as test data. And copying and pasting the data like this is very dangerous because you really have to check that it is the correct shape and everything is as you expect it to be, because otherwise you copy and paste the wrong value and then the test passes because you've got bad data in the test. So it's a risky one, but you can save a bit of time if you verify it. So let's get rid of the word object, like so, and then we've got a huge, great object in there. Oops, I managed to copy and paste it into the terminal. And let's give that prettify, and there we go. Now we've got a very, very large set of test data. And that data 5 yeah, looks about right to me. 2, 1, 2, 3, yeah, is that one? Is that the right date? Yes, it is. And then the other one, 213, 213. So that all looks pretty good. And the DynamoDB code's relatively straightforward. So, you know, the likely errors are we've put the wrong ID in here, we've got the name and the ID all the wrong way around or similar. So that looks good enough to me. And of course, you can go and stare away at this and get someone to do a pull request review if you really want. So we've got some really large test methods here, mainly because of the size of the DynamoDB data. I'm going to leave it in the tests for now. I don't mind tests where they've got a lot of verbosity and they're pretty long if it's not a lot going on in the test. You know, this is just a big bit of test data. We can collapse that in the editor, see that it's doing a put item command, and then verifying the results, and we can check through that as and when we like. But again, that's my personal preference. You might want something different. So let's see if that test now passes. And it does. Great. So we've got 2 to go. So this one is when a record exists already and it hasn't been updated since we retrieve it, it saves it. And then when it has been updated since we retrieve it, it throws an error. So let's do this one first. So we do want the data to already exist in our table first. So let's go and copy this test data setup where we're putting an item in. And let's change it again. So the key is instead going to be 2015 in May, the 10th of May, why not? I'll do the same for the record date. And I'm going to change all of these dates to match, but I'm going to leave the rest of the test data the same. I think that's okay as long as the dates are relatively unique. It's not too hard to find which test the data came from. Cool, so we've got that data there, and then we want to save that record again, but not by using DynamoDB to put it in there. We want to do it based on the DynamoDB data store. And you see that all of my tests have the same sort of structure. They do a load of setup, then they do some operations, like putting an item in, so here, and then they do some assertions at the end to make sure it's all okay. And I like that structure. I've seen it as AAA before, arrange, so you get everything ready, act, perform actions on your test subject, assert, do the expectations or the assertions, and I like that structure. I think it makes for good tests. So we've got that there, and we've got data store. We're putting some data in DynamoDB. Then we're going to call our own method. So we're going to expect the data store dot put day record. We've got to give it a record, and it's going to resolve to be undefined because it returns promise void. So now we've got to take the huge DynamoDB version and turn it into the sort of friendly object version. So let's pop that in there. And let's do that. So we don't have key anymore. Record date's now called date, and it's just the string. Same for last updated at. Merge requests is now just a simple object rather than an object with a big M in it. And ID is a string. Author is an object without the M. ID is a string here. Name is a string here, like so. And then we can have title, which is a string. Project, it's an object. And ID, whoops, I've deleted the wrong bit. There we go. Like so. And name, good. Status is just a string. Create stat is just a string. And then we've got to do it one more time. Gets old doing this. Gets old doing this with DynamoDB, but for a lot of use cases, it's a very good choice. It's really about what is right for your use cases and your team and whatever else. If someone tells you that a certain database is right for every use case, they're lying to you, or they don't know, because you've got to make a good assessment on the project and the use case and the people before you can work out what the right database is. Have I got how many? Right, what's gone wrong in the shape of this test data? Where have I got something wrong here? So author, yeah, project, yeah, that looks fine. That ends that object. That ends that bracket there should end the merge requests object. Whoops, we have got too many brackets because I've taken this from the DynamoDB form and don't like that. String is not title type merge request. Have I got some, oh yeah, I've got another set of excessive brackets. Here we go. And then that is the end of that one, and that is the end of that one. Okay, cool. So I've taken the DynamoDB form, put it into an ugly looking set of the real data we want, and so now I can check if that works. Oops, sorry, I've run the prettier again. Cool, so that one works, that's nice. Which means we've got one test remaining to write. So I'm going to copy all this lot, and I'm going to put it in like so, and I'm going to get all the way down to this pop this in here, and I'm going to quickly scan through the data here, and I'm going to change it again. So let's do June rather than May for this test data. And then the test data is relatively unique. It's relatively easy to find which test the data's for, which can be really helpful, especially when you're putting stuff into real databases. And you end up with a load of records, and you're like, where are these records coming from? Or if you have conflicts between different records, you think, well, what's going on here? So this time, rather than having the same last updated at date, we want to simulate a case where someone has called the getDayRecord method. That gives them a big object with a load of stuff on. Then they've done some computation, they've done some work, then they come back to it. Let's say they've modified it slightly, updated one of the merge requests, and they want to put it back in the database again. And if someone else has modified the data in the middle of those two things, in between them getting it and putting it back in again, then it means that we are going to lose those changes when we call putDayRecord. So data's going to get mangled or lost. So what we'd like to do is to make sure that no one else has put data and changed that day record in between us getting it and us then trying to put it back in again. So only one person can have it at once. So where we are putting the data into DynamoDB, we're going to pretend that this data already exists in here. This day record already exists in here, but someone else has changed it. So it was last updated, I don't know, 27 minutes past 10. So then when we go to try and put the record back in again, the last version we saw, the last copy we saw was 25 minutes past, but someone else has changed it since. So that means that we can't save our record. So instead of getting instead of resolving, we want it to be rejected. We want this promise to be rejected. And we would like really kind of like a nice descriptive error message. So it could be something like data has we could say data for day, and then let's put the day in here. So oops, I can't do interpolation in a regular expression. I don't think we need it to be a regular expression, to be honest. So we have the data for the day. Oh, we can just put the string in, why not? And let's go back to regex in case we put some extra detail in the error that's not covered here. Data for this day has changed between our last changed at of. So the one we've got is this one. And the current last changed at of. So this is a really verbose, long error message, and some of you might not like that, and that's fine. You don't have to like it. But I want it to be very, very specific, very, very clear about what's happened, so that you can understand what the current state of the data is, what happened, and why we can't do this. So now if we run this, what we'll find is that the test fails because we haven't built in the functionality to ensure that no one else has changed the data since we last looked at it. So we're going to use conditional writes to do that with DynamoDB, and so we need to add some extra inputs to our put item command. So we're going to add a conditional expression and conditional expression. Sorry, not conditional expression. Let's go and look at the docs for that. So we've got conditional operator, so that's a legacy one. Conditional expression, yeah, that doesn't have deprecated on, and expression attribute names. So a condition that must be satisfied in order for a conditional put item operation to succeed. An expression can contain any of the following: Functions, attribute exists, attribute not exists, attribute type contains, begins with, size. Then we've got some operators, and then and, or not, or similar. And then we've got condition expression attribute names. Is that related to condition stuff or not? No, I don't think that is. Okay, so we've got to do a condition expression. Let's go and have a look at the docs for that. There's a handy link to the docs. So let's look at the condition expression. So we can check that an attribute does not exist. Well, we don't really want to do that. We want to check the value of the attribute instead. So there's a delete there. So the product category is in one of those two. Price between those two values. We really just want a simple equals. I wonder if there's a simpler equals. So price greater than limit. So it does look like we're going to have to use expression attribute values here. Can't put raw value in. How about this one? So attribute not exists, attribute exists. String starting value element is set. We really want equality. Let's do a comparison operator and function reference. So we've got an equals. I assume that's the same as a double equals. Yeah, true if A is equal to B. Cool. So we want to make sure that the last updated at is equal to, and then we've got to make a expression, which we'll also call let's call it our last updated at. So it's just a bit clearer that it's a different thing, different value. Then we've got to use the expression attribute values. We'll probably have to use the names as well. Let's go and read the docs for that because I'm not super familiar with how that works. So you set a expression, right. Use the hash character in expression to do reference an attribute name. I'm going to have to go and read the docs for this one as well because I'm not super clear on how it works. Let's see an example. So, okay, that's not super useful. There's probably, I think there was an example on the previous page we were just looking at with this one here. So let's go and look for expression attribute values. Oh, values.json. Oh, here we go. So this one isn't using expression attribute names, it's just using values. So let's see if we can get away without using expression attribute names. Let's just use the values, and then let's have an object. And so we're going to have a key of our last updated at, and then a value which is going to be a string of the record.last updated at. Okay, so let's see if that works. Oh dear, we've got two failed tests. So the test where we want it to fail has failed with a conditional check failed exception, which looks good, that's cool. However, we've broken some other functionality. So if you imagine for this use case, when there's no existing record, that value isn't going to exist. That's on our condition check. The last update stat isn't going to exist because there's no existing record. So let's add another condition to this, and we can say attribute not exists. I think that's what it was called. Or so it doesn't exist. There's no existing record, or the last update stat dates match. Let's just double check I've got the right function name there. Attribute not exists. Or maybe I've got it wrong. Attribute not exists. Is that right? Oh, that is right. Okay, so cool. Let's try that again. Okay, good. So we're down to one test failure, so we fixed the other method. However, we don't have a nice descriptive error message, and that's something that we did want. So let's go back to our putDayRecord method, and let's whack a catch onto the end of that for an error. And we can say if the error's name equals, because we use triple equals in JavaScript or TypeScript, is that value, then we're going to do something custom with it. Otherwise, we're going to rethrow the error that we cut in. So if it's any other error, we just pass it straight through. But if it's this error, this particular type, we're going to do some custom handling. So we're going to throw our own custom error, and we're going to say data for day, and let's make this a template string so we can do some interpolation. And let's do record.date. Let's see what our test says. It has changed between our last changed at of. So let's copy that bit in there. Save us typing it out again. And so our last changed at is going to be record.last updated at, and the current last changed at. So I don't know if we can actually get the current one very easily. I'm not sure how we can get the current version. I wonder if there's a feature in this to do that. So put item command, what can we do with put item? So we can do item expression attribute value, filter expression, conditional operator, scan. Oh, I scrolled too far. Sorry, I've scrolled too far. Put item input. Here we go. So we're not using that one because it's deprecated. So we've got return values. Comes with old items returned. So we're not doing an overwriting because the condition check is going to fail. So we probably can't use return values. Conditional expression. So it might be difficult for us to get that value back. Okay, let's for now leave that error message dangling here in our custom error. Let's stick a breakpoint in there, and let's go and do some debugging. So rather than running npm run test, which is just calling Jest, if we're going to have a look at the package.json script, it's just calling the command Jest. So package.json, here's the script, here's test, and that is Jest. So rather than running Jest, we can do a debug version. And so if you look into node modules in your project .bin, node modules /bin, you can see we've got all the binaries here that we can call with npm scripts or npx. And so if we go to node modules bin Jest, and if we call that as a program, then it behaves exactly the same way as if we'd called Jest ourselves. And then we can add other options to that. Because it's just a JavaScript file, we can run it with Node as well, like that. And then we can add Node options like the inspect options or inspect break. So inspect break will pause the application at the start of the Node runtime before any codes run, so we can get a debugger attached and do some work. So let's do Node inspect break, and then the name of Jest. Didn't copy and paste that. Come on, copy, paste. There we go. So you can see nothing's running, and we're waiting for the debugger. So let's get the debugger on there. I'm using a feature of WebStorm, or like the IntelliJ-based IDEs here, to attach to a Node debugger. But you can do the same with things like VS Code really nicely. They've good support for that. So the error is not tremendously helpful. So it's a conditional check failed exception, but it's not got any detail in about what that check was, or anything really we can do about it, which is kind of pants. And we could, if we wanted to, get the record's real last updated at by querying it again, but I think we'll just simplify this error message and we just won't include that. So we say day for day has changed between our last changed of this value. And so we'll just leave it at that. And in practice, we might need more information if this is going wrong frequently. But we'll leave it as that for now, and we'll update the test to just check for the first bit. So let's run that again. Oh, sorry, I'm still in the debug one. And that all passes. So we've written some tests for our DynamoDB day store. Let's go and have a look at the coverage folder again, an LCOV report, and we can see where we haven't got stuff that's covered. So services DynamoDB day store has got some bits that haven't been covered. And so we haven't checked that any other pass-through errors or any other random errors still behave correctly, still behave as expected. And it's up to you, whether you think there's much value in testing this. If you've got custom error behavior, I think that's something where it can get very hairy if it goes wrong. So I'm tempted to do that. So we've got to think about what can we do to make this fail but with a different error. So I'll tell you what, one thing we could do. Let's go and add in another test case. So let's add a describe just outside of, just after this one. Let's say when DynamoDB DB returns an error that's not a conditional check failure. And then we can say it returns the error, because we want the real DynamoDB error. And so then we can make a new client again. Whoops. Let's get the data store set up from another method. But this time, let's give it a different table name. Let's give it a table name that doesn't exist. Let's call it fake table like that. So we know that table names with the table name we've got in other tests plus the little suffix is never going to work. And then we can say await expect the data store dot put day record, and we're going to need a valid day record. Oh dear, this is getting very verbose very quickly. So here's a record, and let's pop this in the test method. And again, let's change the dates just for good practice to make sure that the test data is nice and easily identifiable. If we need it to be, let's pop that in there, and okay, that looks good. So save our record, and then it should reject to throw, and then I don't know what the error is going to be. Let's just put in a regex for something like not exists, and we might have to fix that in a second because I don't know what the actual error is going to be for that one. So we run it. We get a failure, and the error is resource not found exception, so not the word not exists, but we can pop that in there, like so, run it again, and now it's all happy. And you can see that for our DynamoDB data store, we have 100% test coverage. So that was a bit of a run through of my approach to building something using building like the data layer of something and testing that in a real database. Obviously, there's a lot of very opinionated stuff in here about test method layout, test framework we're using, how big the methods should be and where you should store stuff, but hopefully it gives you some ideas at least. And being able to do the debugging of your whatever test runner you use, be it Jest, Mocha or similar, is very, very handy with that inspect option and your editor's support. Because like if you've got a decent idea, it will support that, because that's very, very useful for seeing what's going on in tests. It saves you lots of console logs and similar. Check out the rest of the series when it's made for other code alongs in this project.